One wrong step can turn your dream hike into a nightmare. It all started as the perfect day, a chance to disconnect and explore nature's beauty, all packed and ready to go. But nature has its surprises. That was a close one, but now you're alone, injured, and without a lifeline. Hopelessly lost, you start to wander the wilderness alone, just to find you've been going in circles all along. If only you had a portable charging system for your phone. Introducing the ChirpChaser, the ultimate companion for every hiker. The ChirpChaser is an easy-to-install, portable turbine for your off-grid power needs. Stay prepared, stay safe, and enjoy the adventure. Side effects may include mild drowsiness, dry mouth, dizziness, and in rare cases an unusual sense of calm that feels suspiciously like joy. Some users report occasional stomach discomfort, temporary confusion, or sudden clarity about life's purpose. Results may vary. If you experience uncontrollable euphoria, overly deep conversations, or an unshakable urge to nap, consult your doctor immediately. ChirpChaser. Power up, bird down.
Hi, I'm John, and I'm going to tell you about this wind turbine.
Alright, so this is our turbine. First, we have the power unit. It's a buck boost converter hooked up to a full bridge rectifier, which is hooked up to our stepper motor, which is the generator. It's all secured inside of this 3D printed base where we have 2 ball bearings and a steel shaft. They go through this base and secure to this red part here. This red part holds the walking stick and also mounts to the gear. It transfers all of the torque into the generator. That's how we make power. Now, the sails are made out of kite fabric, and we use snap swivels and eyelets to secure all of the pieces in place. We use fiberglass rods, which are bent using the tension of these strings and the fabric, and they're secured into these 3D printed parts right here. Now, this whole assembly is a little bit unstable. That's why we have this bracket up here. It pins into the ground in 3 positions, and it's got a bearing, so it allows this whole thing to spin and be very stable the whole time. And that's about it.
Hi, I'm Hayden. I'm going to be showing you how to turn this into this in an overly dramatic 30-second montage.
Hi, my name is Jacob, and I'm going to be walking you through the testing components we used for our turbine. We started by measuring wind speed using a digital ammeter. We measured the power output through a voltage readout down on the bottom, and current measurement through a digital multimeter.
This is the RPM versus wind speed graph, where wind speed is measured with a 4% tolerance in miles per hour. The wind turbine begins spinning at a wind speed of 4 miles per hour. The RPM is calculated by counting the revolutions in a minute and confirming with the anemometer that the wind speed has stayed consistent. For wind speeds between 0 and 8 miles per hour, a fan was used, and for higher wind speeds, ambient wind was used. This test was limited to a wind speed of 13 miles per hour due to the fragility of the sails. Improvements on the sails will be mentioned later. This is the voltage versus RPM graph. At 4 mile per hour wind speeds, the turbine spins at 9 RPM. As you can see, no voltage is read by the USB module at this low speed. At 5 mile per hour wind speeds, the turbine begins producing a readable voltage. The amperage during these tests is 1 amp at 15 RPM and grows slowly to 1.3 amps at 40 RPM. At 6 mile per hour winds, the turbine generates 5 volts at approximately 1 amp, resulting in 5 watts of power, which is enough to charge a phone.
Hi, I'm Hunter, and these are our future plans for this design. Before demo day, we plan on reprinting this base because, as you can see, that's cracked there, and there are also some changes such as the spacer is a redundant part with the new base design. We need to change this pull-to-gear interface. There's only a small section connecting to the rod, and lastly, we need to double layer the fabric in a lot of spots to reduce any breakages of the fabric. As for our next steps after demo day, we plan on changing the base so that it's just one length instead of variable length for different gears. Electronics could certainly be waterproofed a lot better than we have it right now. It's not very resistant to weather. We could make this more compact, make these fiberglass rods that support it fit into the hiking pole, but currently that doesn't work due to screws. The motor could be lighter to reduce weight for anybody backpacking. The gear would of course change to a material that's not a weak material like acrylic that's prone to deformation in wear. And finally, we could do better clips. Instead of these little fishing clips, we could do carabiner-like clips.
How did I miss that? Oh, I totally missed that.